Okay, all right. So let's, so put your hands down. Hey, write it down so you don't forget, because I know you're going to forget. All right, now, so here's what we got to talk about. Okay, number one, we got to talk about section 4.2. This is the last day of it, about just the one problem. Then we're going to move into technically section 4.3, which is story-based problems, and I've got a couple examples of them. I just want to do one today. We'll save a bunch for tomorrow. We'll probably have a question of the day tomorrow, but we won't get a big assignment, not like today's. Remember, the assignment I gave you yesterday is due tomorrow, so keep that in mind. I'll give you some time to work on it if you haven't finished it yet. I know some of you just kind of leave it open, just kind of finish it as you go. But let's kind of jump in. This is the one problem that I kind of warned you of yesterday. I believe this is the example that's in the actual homework. Yeah. Okay, so what you have to do is you had to find your table, and you had to figure out, how to describe, critical points and all that good stuff. Okay, so on this one, we definitely have two set x's. Now, what we have to do is we have to find the critical points. So, just make it number one. Okay. Just kind of waiting. All right. First of all, when we actually get through this, here's what we have to do. We have to find the first derivative. Now, I know this is a fraction. I'm still going to do it as a quotient rule, and I'm going to show you a shortcut for how you find critical points and inflection points. So, I'm still going to do the first derivative as normal. So, it's derivative of the top times the bottom plus the derivative, minus the derivative of the bottom times the top all over the bottom squared. And I know that when you do quotient rule, like, the fractions just get bigger and bigger and bigger because you're always squaring the bottom. So the fractions actually grow when you're taking derivatives of them. In theory, the top is what's getting smaller. The numerator, the top, is actually the most important piece. That's how you actually find critical points. It's the numerator, because it doesn't matter the denominator. You don't worry about getting zeros in the denominator. There's exceptions where you can't have numbers down there. Like, there's no way I can make the bottom 0 right now as it is, because I'm adding numbers together and squaring it. Like, there's no numbers I can make the 0 on the bottom. The top is what I'm actually worried about. If we simplify the top, this turned out to be x squared plus 3 minus 2x squared minus 2x, right? That's simplifying the top by just distributing. I don't really care about the bottom. I'll just leave this down here. I'm not going to FOIL it out or anything. I don't care about it. And this is still the first derivative. I'm not taking any part of it. If I simplify the top, that's actually what I care about, because if I can figure out what makes the top 0, that's a critical point. Or if I take the second derivative, that's the inflection point. So that's what I want you to think of. So when we actually simplify this, the top actually ends up being a negative 1x squared minus 2x plus 3, right? That's the numerator. I don't care about the denominator. So I'll just leave this. I'm not even going to FOIL it. I don't really care about it. So the top, and still, this is still first derivative on this problem. Again, this is the actual homework problem that you had. What we do is we have to just figure out what makes the top 0. So you have to factor it, if possible. So I don't know if this is even possible to factor. So let's figure this out. So I'm going to pull out a negative 1. That's x squared plus 2x minus 3. So yeah, that thing is factorable. I'm not going to even worry about the bottom anymore. Factoring the numerator on the top, since I pulled out a negative 1, because I don't like to have that negative sign out front. That just throws me off to figure out how to factor this thing. It ends up being a plus minus, because the minus sign in the back with the 3. We break up the 3 to be 3 and 1, and x, and that does make the 2 in the middle, positive 2 in the middle. And so I do actually have 2 critical points here. Which one?
We're good. No. We're good.
Okay. All right. So the actual critical points of the denominator, or of the numerator here, is negative 3 and positive 1. Right? Those are the potentials. But Brody, say it out loud.
Just one.
Yeah, we have to throw out one of them. The reason why we have to throw out the negative 3, we're going to throw this one out. It didn't fit in the boundary. So that means I only have one critical point I actually have to worry about, and that's positive 1. Okay, does that make sense? We did all that work just to figure out one of them isn't going to work. Now, when you do this next part, so now I got to figure out the concavity and figure out kind of how to draw this thing. I'm going to plug numbers. I'm going to plug numbers in between here, and I'm going to plug these in the first derivative to figure out if it's going to be positive or negative, to figure out what my curve is doing. Maybe it's going down and up. Maybe it's going up and down. But I'm going to plug a number. So in fact, I'm going to plug 0 in. That's a number between -1 and 1. And remember, I have to plug it in the first derivative function. Because this tells me the slope. I really want to know the slope, and that's what I'm putting here. So on this, if I were to plug in 0 in the first derivative, I get 3 over 9, which is 1/3. If I plug zeros into all the x's on that, how I'm doing that so fast, I'm using the part in blue. I plugged in zeros to all the x's, so it ended up being 3 over 9 on the bottom. So that's 1/3, so that was positive. So my slopes here were positive, so that means it was going up. So if I was drawing like a mock picture, it's probably doing something like this. That's what I'm betting on. But I haven't done this right side yet. I don't actually know if it's going up and down. I got to figure out this other part. So going on to the other side of 1 and 2, I'll plug in 1.5. So taking this big, in fact, I'll type this in my.
Are they plugging in the first derivative?
So I'm going to plug in 1.5 now. Squared minus 2 times 1.5 plus 3. So this is the numerator. The numerator, the top, if I plugged in 1.5, turns out to be a -2.25.
You're plugging this into which one? The
blue one. I'm using the blue, the first derivative, to figure out where my derivatives are going. Because I'm just trying to figure out what the slope. I'm trying to figure out what these slopes are doing to get kind of a picture in my head what this graph is doing.
Do you type in the original? I keep forgetting.
I only type in the original to figure out what the boundaries are. If it was like what the actual values are for max and mins. I don't need to do that here.
If they don't give you that.
Yeah.
Okay.
So, all right. It looks like if I actually plugged in 1.5, it actually ended up being negative, like I said. So these ended up being negative on this side. So I was actually right. It was actually doing this. So this point right here is actually going to end up being a max on this graph. So on Google, if I was typing this in, critical point at +1, it's a max. And then the next thing I do is go into the second derivative and do the same thing, figure out concavity. When you do second derivative, I'm going off to the one in blue. Because I don't really care, because when I do the second derivative, you're just going to do that, and then you're going to simplify the top again to figure out any inflection points. I don't care about the denominator, so I can really just kind of forget about it. So it'd be the derivative of the top, which is -2x minus 2, times the bottom, which is that mess, minus the derivative of the bottom, which is a chain rule, times the top, and then you simplify it all, and it would be a mess. I know it would. And you can kind of figure out if there's any inflection points at all. It looks like I think a bunch of things cancel on that.
But we don't need to know how to do this.
So on this problem, you technically would, because you have to check to see if there's a. I think on this one it doesn't actually have an.
Yeah, it does.
It does.
It does.
So.
Pretty sure.
It does or does not have what?
It asks for the inflection and concavity. I'm pretty sure.
It says critical points.
Did it? No, but on this picture, did it do anything else other than that?
No.
So I don't think there would be an inflection point. It didn't change to go back to positive, did it?
No.
In that
So
boundary?
you don't have to show it.
I don't think so. I don't think there would be.
Because that's it.
So you don't even have to show your
No, I wouldn't even have to worry about second derivative on this one, because I don't think it's bowling back upwards.
I have no idea.
So there's no point of.
There's no point, because I know it's going to be concave down over the whole function. So, yeah, just by knowing that graph, I can tell you it's concave down. It's not bowling back upwards. It didn't change directions again. So I didn't even need to worry about the second derivative.
No, it's because when you plug in a number for the second derivative, it's over out of the boundary.
Yeah. Yeah. Okay. All right. Questions? Okay, I'm going to give you the guys the rest of the time to work. Now, tomorrow, here's what we're looking at, because I did want to intro what we're doing. Tomorrow, we're looking at story problems, like this, or I'm going to flip through some other slides here. We're looking at story problems, figuring out max and mins on story problems.
65 to 69-ish.
Yeah, these were in your pre-calc book. So I was picking out problems in the pre-calc book where it said find max and mins. Well, we're going to do the same problems we did back in back in pre-calc, but we're going to use calculus to help us solve these faster. And I'm going to show you that stuff tomorrow, introduce it. So you get to see like the things we did in pre-calc and now what we do in calc and how it gets way easier now that you know shortcuts now.
As long as
So.
it's easier.
Trust me, the stuff you're doing now is way easier than what we did in pre-calc.
Okay.
So I know it doesn't seem like it, but it is.
Laura, do you have to put a hairspray in, or does it stick up automatically?
I don't know. I'd put some gel in it. I don't know why. I don't know why. Yeah. There's not much for hair, but I do.
No, Lord, it works. It works. Okay, my actual question, here it is. Can we please give Wyatt a dirty mullet tomorrow in class? I'll bring the clippers.
No.
Why?
No.
You know how awesome that thing would be?
No.
Why you need to
No, absolutely not.
Absolutely not.
Wasn't asking you, Wyatt.
just slick